Hi guys, my name is Ty Raffensperger, and my essay that I'm going to be talking to you about is on quantum computing and its future place in society and how we could possibly be using it. The reason I decided to research this topic is because my major is computer engineering. I have experience in software and hardware, and I feel like this new generation of computing is going to really change the way that we look at computers and how they operate. The thesis for my project is the progression of quantum computing has drastically increased in the recent years. The technology behind quantum computing allows these systems to perform calculations deemed impossible for classical computers. They are devices that will change the way we compute in our everyday lives. What I'm basically trying to say here is that this new revolution of computing is going to make such a huge impact that we really aren't able to gauge it yet. Just like in the past, whenever scientists created classical computers, they honestly had no idea what they were getting themselves into or the potential of these computers. Now begs the abstract and quite scary question, what is it? Well, the best way to describe it would be to compare and contrast quantum computing with classical computing. To begin, we know classical computers operate in bits, which are binary numbers which can be a 0 or a 1, an on or an off, an up or a down, etc., etc. Quantum bits can operate as a 0, a 1, or both, depending on how you mix the bits together. This is what makes it such an interesting, abstract, and quite difficult concept to grasp. Speaking of concepts, there are two of them which quantum computers ride off of, superposition and entanglement. These two concepts can be explained from a very top-level perspective as how the output of quantum bits will change if they are mixed together in certain ways, thus giving a quantum bit more properties than a 0 or a 1. You can also picture quantum bits as a real and complex portion of a number or of a bit. They have a real side and they have an imaginary side, which can only be achieved or observed if mixed together with another bit. So now that you have some background knowledge on quantum computing and quantum bits, what's the point of it? Well, we know that quantum bits work exponentially faster than classical bits. They can solve problems in a much quicker manner compared to computers that we have in our houses and in laboratories today. It's hard to provide a number or a calculation because most of the results that we have and most of the theories are as that, theoretical. There are many real-world examples that we have about solving algorithms or solving problems that will take weeks to months from a classical computer, in which theoretically a quantum computer could solve within minutes or an hour. Quantum computers can have a big presence in certain fields, such as the medical field. There are a lot of chemical analyses, cell simulations, and other types of virus treatments going on where we try to simulate what would happen if we did this with this cell and just see what the output could be. The thing is, with classical computers, it takes a very long time to get results from this. For astrophysicists, sometimes people will beg the question, what happens if a star explodes? What happens to the planets around it? What happens to the surrounding solar systems? Well, with quantum computing, we can drastically reduce the amount of time it takes to complete these simulations and get actual results. The last real-world example I have with quantum computing is actually a double-edged sword because it's great that we are able to do it, but it could pose as a danger to other nations around the world. Most of our secured information and our passwords are encrypted with a certain type of code. Quantum computers could possibly excel and beat this code within a matter of minutes, depending on where you point and shoot it. This could pose as a great master key for many powerful governments, but it could also pose as a very big danger because with just a click of a button with a successful quantum computer, people would be able to have all of your private information and all of your data. A couple of other obstacles and counters we have with quantum computing is that it requires an extremely low temperature, somewhere around the temp of zero point zero 0.07 Kelvin, which is almost near absolute zero, which is very difficult to achieve. The cost of more research and the general cost of quantum computers will be astronomical in the beginning. Hopefully it'll be able to go down over time, just like classical computers have. The last obstacle I have is integration into our daily lives, because humans are generally resistant to change. Quantum computers will be a very big change into society, and it'll be something that we'll have to get used to. Many organizations around the world have been dumping money for the research of quantum computing. It can almost be seen as the space race of the century. Which country is going to get the most powerful quantum computing working first? So I'm running out of time, but to conclude, these quantum computers that are going to be coming around in the following decades are going to be powerful. Really, really powerful. I think a great integration into society is going to be the black box concept, where we have classical binary hardware operating before and after the quantum piece, but we can put it into computers in the near future as a middleman to do the difficult calculations before they're sent back out with classical bits. Thank you guys. Have a nice night.